Let's try to evoke the difference between a digital and an analog signal. The analog signal was examined at the beginning of week 2. When we started the visualizer, we saw the signal changed swiftly. The value was changing from 0 to 5V. The digital signal can either be present or absent. It will either take the value of 0 or 1. In Arduino pin terminology, this is either high or low. This means that when we record a digital signal, we write digital write high, and we put the value of 5V at the specified output. And when we write digital write low, we set the value of 0V at the output. Now we are going to learn how to read off digital signals. We will also try to determine whether or not there is a voltage at the input. While reading off the signal, the controller will be determining whether the current voltage is higher or lower than 3V. Thus, the low or 0 value will be assigned to anything lower than 3V, while the high or 1 value will be given to voltage higher than 3V. Now we are going to prepare a sketch to experiment with. In this experiment, we will be transmitting everything that is passed to input 7 directly to the inbuilt LED and output 13 to make an input and an output out of the 7th and the 13th pins, respectively. We shall start with the pin mode function designation in setup. For LED pin 13, this will be output, and for digital in pin 7, this will be input. Our loop will consist of recording the digital signal on LED pin, leaving it in the same state that our digital in pin is now. Now we need to receive this digital signal at input 7. For this purpose, we shall assemble a simple circuit. A simple tact switch will help us receive the signal at input 7. The same switch we used during week 1 to manually control a traffic light. At one end, I have connected it to the 5V Arduino output with this red wire, and at the other end, I have used this white wire to connect the switch to input 7. Consequently, when the tact switch is on, the 5V voltage will be transmitted to input 7. We will determine high voltage level and will transmit the signal to output 13. Let's try and see if this works. Yes, it really does work. I will now say a couple of words about the resistor which I connected at the same end that has a wire connection with Arduino. This is the so-called pull-up resistor. It is connected to the ground link on the breadboard, which in its turn is connected to Arduino's ground link. We need the resistor in order to prevent the switch from picking up any noise that always exists on air. I can remove it from the circuit and we shall see that the LED is on when the switch is off. When I press on it, it will be brighter, but during the rest of the time, input 7 will be receiving voltage which is perceived by the controller as high, so the LED will also be on. Now, let's look at the sketch again. I am suggesting an alternative. To get rid of the noise on air, we shall configure the output destined for the switch and marked as digital in, not into a simple input, but into input pull-up. What is it exactly? It turns on the pull-up resistor, which is built in Arduino, although in this case the pull-up is performed towards the voltage supply and not the ground link. Some people separate the terms of pull-up resistor and pull-in resistor, but I'm used to calling it a pull-up resistor as it pulls the switch up either towards the ground link or the voltage supply. As a result, the input pull-up pulls the switch up towards the voltage supply. To make it work, I have set the second output of the switch from 5V to ground. And now, look how the LED is on when the switch is off. Thus, when the switch is off, high voltage exists at the input because of this input pull-up function. When we press the switch on, the voltage disappears. Therefore, the switch operates vice versa. This method is more convenient in my view, as it simplifies the scheme. Moreover, we can get rid of all this input noise by changing only one single parameter. To conclude, We have learned to read off a basic digital signal. Why do I say basic? All digital devices that surround you communicate with each other in a more intricate manner than just through yes or no signal or no signal. They use pre-agreed communication protocols where it is discussed and agreed in advance what the combination of high and low voltage levels in certain periods of time signifies. We will later have to deal with sensors, which use complex protocols, but this will happen over the course of the upcoming weeks.